As the name suggests, the difference of two squares implies that the algebraic expression to be factorized consists of only two terms. The two terms are separated by a minus sign. And each of the terms is a square number. In other words, both terms have a perfect square root. The expression a squared minus b squared contains only two terms. The two terms are separated by a minus sign. And both terms have a perfect square root. In other words, the square root of a squared is a. And the square root of b squared is b. If, and only if, all three of these criteria are satisfied, may algebraic expressions be factorized using the difference of two squares. Before we continue, bear in mind that, whenever factorizing algebraic expressions, you should always look for a common factor first amongst all the terms, before attempting to factorize using any other method of factorization. To factorize a squared minus b squared, proceed as follows. Open up double brackets. Place the square root of the first term as the first term inside each set of brackets. In other words, since the square root of a squared is a, we place a as the first term of each set of brackets. We do likewise with b squared. The square root of b squared is b, so we place b as the second term inside each set of brackets. The last thing we need to do is to place opposite signs inside the brackets. The order is irrelevant, because when we multiply out the brackets, the inners and outers will cancel out. To factorize 4x squared minus 9y squared, first note the following. We first look for any common factors, of which there aren't any. The expression contains only two terms, which are separated by a minus sign. And each term has a perfect square root. We can therefore factorize this expression using the difference of two squares. So, open up double brackets. Place the square root of 4x squared, which is 2x, as the first term inside each set of brackets. Likewise, the square root of 9y squared is 3y, so place 3y as the second term inside each set of brackets. Finally, place opposite signs inside the brackets. 4x squared minus 9y squared therefore factorizes as 2x plus 3y times 2x minus 3y. You should always check your work, so multiply out these brackets to get the original expression. Factorize 25p squared minus 1. This expression does not contain any common factors. There are only two terms, separated by a minus sign, and both terms have a perfect square root. The square root of 25p squared is 5p and the square root of 1 is 1. 25p squared minus 1 therefore factorizes as 5p plus 1 times 5p minus 1. Factorize 4x squared plus 1. There aren't any common factors amongst the terms, so we cannot factorize using common factor factorization. The expression contains two terms, both of which have a perfect square root. The square root of 4x squared is 2x. And the square root of 1 is 1. However, the sign separating the two terms is a plus and not a minus. We therefore cannot factorize this expression using the difference of two squares. The expression therefore cannot be factorized. Factorize 16x to the 4 minus 1. There aren't any common factors amongst the terms. The expression contains only two terms, separated by a minus sign. And both terms have a perfect square root. We can therefore factorize the expression using the difference of two squares. The square root of 16x to the 4 is 4x squared. And the square root of 1 is 1. Place opposite signs inside the brackets. This expression can be factorized further, since the second set of brackets contains two terms, both of which are square numbers. The same is true of the first set of brackets. However, the terms within these brackets can't be factorized since the sign separating the two terms is a plus sign. We can, however, factorize the second set of brackets using the difference of two squares. 4x squared minus 1 factorizes as 2x plus 1 times 2x minus 1. 16x to the 4 minus 1, therefore factorizes as 4x squared plus 1 times 2x plus 1 times 2x minus 1. Factorize 3 minus 48x to the 4. This expression contains only two terms, which are separated by a minus sign. However, the terms do not have a perfect square root. We can therefore not factorize using the difference of two squares. At least, not yet. The first thing you should always do is to look for a common factor amongst the terms. There is a common factor of 3 amongst these two terms, so we take this out as the HCF, to give us 3 times 1 minus 16x to the 4. The terms within the brackets can now be factorized using the difference of two squares, since both terms have a perfect square root. 1 minus 16x to the 4 factorizes as 1 plus 4x squared times 1 minus 4x squared. The first set of brackets, 1 plus 4x squared, cannot be factorized since the sign separating the two terms is a plus. However, 1 minus 4x squared can be factorized using the difference of two squares. 3 minus 48x to the 4, therefore factorizes as 3 times 1 plus 4x squared times 1 plus 2x times 1 minus 2x.